students, welcome to State Council of Educational Research and Training Uttarakhand Dehradun, and I am Manoj Kishore Bhogna, Program Coordinator NEP SCART Uttarakhand Dehradun. In this video, we will talk about Mathematics Class 9, Chapter 9, Circle, and today we will learn and prove the theorems related to circle. First one, the perpendicular from the center of a circle to a chord bisects the chord. Second, the angle subtended by an arc at the center is double or the twice of the angle subtended by it any point on the remaining part of the circle, or we can say the remaining circumference of the circle. And the third one is angles in the same segment of a circle are equal. As we see in our daily life, many examples of circles, like we are seeing here a button of coat or shirt, a wall watch, and a CD. We can see that the front face of all these three items have a same shape. Some other examples like bangles, a cycle rim, and so many other examples we can see in our daily life. And these are the example of circle. Before we go ahead, we would like to go through a small previous knowledge test. And for this, we can scan the QR code displaying on the screen or a link that is on the bottom out part of the screen. Now our first theorem is about perpendicular from the center to a chord. For this, we will take a point A and draw a circle taking some radius. Now on the circumference of this circle, we take a point B and a point C. Now by joining these 2 points B and C, we draw a chord named BC of length 10 centimeter. We also take another chord, and for this we draw a point D and a point E on the circumference of the circle and join these 2 points to get another chord DE, which is also 10 centimeter long. Now we draw a perpendicular from the center A to the chord DE and also on chord BC from the center A. The point of intersection of the perpendicular drawn on chord DE from the center, and the chord DE is F. And if we measure the length of the segment EF, we find it 5 centimeter. Similarly, the point of intersection of the perpendicular drawn on chord BC from the center A, and the chord BC is G. And again, if we measure the length of the segment GC, we also got the length 5 centimeter. It means we can see that the perpendicular from the center of a circle to a chord bisects the chord. To prove the theoretical part of this theorem, we can use artificial intelligence AI, and for this here I am using ChatGPT. We can write here prove that the perpendicular from the center of a circle to a chord bisects the chord, and if we enter this, we can see here we can get the proof of the theorem, and we can use it to write in our notebook, or we can note at any other place that we want to copy it. So this is the written part of the theorem. Second theorem is angle subtended by an arc of a circle. Again, to prove this theorem, we draw a point A, which will be the center of the circle, and we will draw a circle of certain radius. Now we will take 2 points on the circumference of this circle. First point is B, and second one is B dash. And we will join these points from the center AB and AB dash. Now we measure the angle subtended by the arc BB dash on the circle, and we see that the angle BAB dash is 60 degree. Now by this arc BB dash, to measure the angle subtended by the remaining circumference of the circle, we will take a point on the remaining part of the circumference, and we take point C for this. And now we join the points B, B dash to this point C, BC and B dash C. Now we will measure the angle BC B dash, and we find that the measurement of BC B dash equal to 30 degree. Now you can see that the arc BB dash forms an angle BAB dash at center and an angle BCB dash at the remaining part of the circumference of the circle. Here we see that BAB dash, which is the angle subtended by the arc at center, is equal to 60 degree, and the angle subtended by the same arc at the remaining part of the circumference is 30 degree. It means the angle subtended at the center by an arc is twice of the angle subtended by the same arc at the remaining part of the circumference. We check by another example, and we take a point D and a point D dash on the circumference of the circle, and we will measure the angles by this arc D and D dash on center and the remaining part of the circumference. So we join the AD and AD dash. We measure the angle DAD dash, and we find it 90 degree. Now we take a point in the remaining part of the circumference and we take E. Now we join DE and D dash E and we measure the angle DED dash, which is the angle subtended by the same arc D dash on the remaining part of the circumference, and we find that the measurement of this angle is 45 degree. Now the angle subtended at the center by the arc DD dash is 90 degree and the angle subtended by the same arc at the remaining part of the circumference is equal to 45 degree. Means once again the angle subtended by the arc D dash at the center is double of the angle subtended at the remaining part of the circumference or twice of the angle subtended at the remaining part of the circle. Hence, we can say that the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Again, to write the proof of this theorem in exams or in our notebook, we can use AI, and for this we can use ChatGPT or any other AI tool. Here I am using ChatGPT and we write here prove that angle subtended by an arc at the center is double the angle subtended by it any point on the remaining part of the circle, and we enter the question. So here we can see that we get the total proof of the theorem in a written form, given, to prove, and the proof. These are the all necessary steps that we have to write in the exams or in our notebook. So we can copy these steps or we can learn it, that how can we write the answer in exams or in our notebook. The third and the last theorem we have taken is about the angles in the same segment. And similarly, first of all, we take a point A as the center of the required circle and draw the circle. Now, if we want to measure the angle subtended by a segment, first of all, we draw a segment on the circumference of the circle. For this, we take a point B and a point C on the circumference of the circle and join point B and C. So we get a segment BC. Now we take a point D outside the arc BC, or we can say the segment BC. Point D is drawn at the circumference of the circle, and we join BD and DC. We join BD and DC. So we get an angle BDC. Now we measure the angle BDC and we find it 56 degree. Now again we take a point E on the circumference of the circle and join the lines BE and EC and measure the angle DEC we find it also 56 degree. Here we can see that the angle subtended by the segment BC on the point D, which is on the remaining part of the circumference, is 56 degree, and by the same segment BC on another point E is also equal to 56 degree. We can check it by taking another point, and for this we take a point F, and now join the point F again to point B and C. So B, F and CF. Now we have to measure the angle BFC, and we again see that this is 56 degree also. So all the angles subtended by the arc BC or segment BC, or we can say chord BC, at the remaining part of the circumference are equal. Angle alpha, angle beta and angle gamma are the angles subtended by the chord BC at the remaining part of the circle, and all angles are equal. So we can say that the angles in the same segment of a circle are equal. And once again, to write the proof of this theorem, we write here, prove that the angles in the same segment of a circle are equal, and we enter the question. We get the solution of this theorem in every step. First one, what is given, what we have to prove, and proof of the theorem, as we have to write in the examination, or we have to write in our notebook. So we can learn from here, or we can copy from here to our notebook. So this is the use of the AI. In this way, we have read or learn all three theorems that we have decided previously. Now we can make a notched assessment of what we have learned in this video, for which a QR code is displaying here. We can scan it and we will get a Google form, or we can also use the link given below. We have to opt the right choice, because in this form we will get multiple choice questions, and by selecting the right answer we will submit it. This will be beneficial for both the teacher and the student itself. They can make their next plan according to the responses that the teacher will get from the students, and students can revise the topics or the part in which they will feel any difficulty, or where they will require the revision of the topic. Thank you.